Hello, my name is Tadiwa.
And my name is Sean.
And this is our Smart Parking API.
Our Smart Parking API makes use of various sensors to detect any free parking slots that are available in a city. The detected data from the sensors is analyzed and information is sent to a server, which then is made available for a user. This allows them to find a desired parking spot location depending on the area, or find their car if they have somehow lost track of where they have parked. Smart surveillance is also implemented by using a camera and sound sensor attached to the device, which will alert the user if there's any suspicious activity occurring around the vehicle, which then allows the user to view live footage of their vehicle. This is a valuable IoT application since information about the parking bay and the user's vehicle is made available by simply opening an application or web page. The hardware modules. For our microcontroller, the Raspberry Pi Zero was used because it met all the requirements and there wasn't any need for purchase, reason being we had already received one from the embedded course. Two motion sensors were needed to monitor the parking bay, and the full description of how they were set up will be explained in detail in the next few slides. The Raspberry Pi camera proved to be essential for the module because it provided the ability to stream live surveillance of the parking bay.
Now for the API overview. Our API makes use of three classes as shown in the UML diagram. The most important class is the Smart Parking API class. This class transfers our relevant live sensor data from our Raspberry Pi to a local web server we have created. For our demonstrator application, we have created a web page which a user can access if he is situated at the location of our hardware module. This web page has a live stream of the parking spot, the current occupancy of the parking spot, and the GPS coordinates of the system. The website changes states depending on the current vacancy of the parking spot, as shown in the user case diagram.
In the top view diagram, we observe a red car that is about to move into a parking area. There are two motion sensors, one that is emitting horizontal infrared rays, labeled PIR sensor 1, and one that is emitting vertically, labeled PIR sensor 2. So as the car is in the process of parking, the length of the car continuously triggers PIR sensor 1 multiple times, and if the number of triggers are satisfied, then PIR sensor 2 is activated. PIR sensor 2 then detects the bottom front of the car, which then satisfies the programmed algorithm that a car has been parked. The process happens also in vice versa when the car is moving out of the parking bay. So when it comes to humans and objects such as trolleys, they will not be able to be detected as cars since they are not long enough to trigger PIR sensor 1 multiple times. This is our demonstration, and this is the PIR sensor 2, which is always at the front of the car park. And then this is PIR sensor 1, which is always at the side. The camera is at the front, also there, with the Raspberry Pi. And now Tadiwa is about to move the car into the parking area. And then, as you can hear, there's a buzzer ringing, which means the car has been parked. And it also changed on the web browser, as you can see, with our GPS coordinates of the place and the live footage. Now is about to move out the car from the parking area. And then the buzzer rings again. And then current state has changed to parking spot vacant. Yeah. We are done. Now Tadiwa is going to walk past the motion sensors to demonstrate that the parking system doesn't confuse cars to humans. For the extensions, replacing the Pi 0 with a more powerful microcontroller would enable the ability to program the camera to identify if or not an object is a vehicle. In this case, the motion sensors will just support the verification when there is poor lighting for the camera to identify accurately.